Yes, indoor or outdoor Category 5e cable can be installed in regular polyvinyl chloride tubing as an extra measure to protect it from abuse without being a National Electrical Code violation. However, it is important to note that polyvinyl chloride tubing must be properly installed and maintained in accordance with applicable codes and regulations. When considering the installation of Category 5e cable within polyvinyl chloride conduit, several factors must be taken into account to ensure compliance with the National Electrical Code and best practices for data communication systems. Firstly, the National Electrical Code does not explicitly prohibit the use of polyvinyl chloride conduit for Category 5e cable. The primary concern of the National Electrical Code is the safety of electrical installations, focusing on preventing fire and electrical shock hazards. Since Category 5e cable is a low-voltage communication cable, it generally does not pose the same level of risk as power conductors. Secondly, the purpose of using polyvinyl chloride conduit should be clearly defined. If the intent is to provide physical protection to the Category 5e cable from mechanical damage, environmental factors, or other potential hazards, then using polyvinyl chloride conduit can be a reasonable approach. However, it is crucial to ensure that the conduit is properly sized and installed to avoid damaging the cable during installation or affecting its performance. Thirdly, the fill ratio of the conduit must be considered. The National Electrical Code specifies the maximum allowable fill ratio for conduits to prevent overheating and to facilitate the easy pulling of cables. While these requirements are primarily intended for power conductors, it is a good practice to apply similar principles to communication cables. A common recommendation is to keep the fill ratio below 40% to allow for adequate airflow and to prevent excessive stress on the cables. Fourthly, the bending radius of the conduit should be carefully observed. Category 5e cable has a minimum bending radius specified by the manufacturer, typically 4 times the cable diameter. When installing the cable within polyvinyl chloride conduit, it is essential to ensure that the conduit bends do not exceed this minimum bending radius to avoid damaging the cable and impairing its performance. Fifthly, proper grounding and bonding of the conduit system may be necessary in certain situations. While Category 5e cable itself does not require grounding, the polyvinyl chloride conduit system may need to be grounded or bonded to other metallic structures to prevent a buildup of static electricity or to provide a path for fault currents in the event of an electrical fault. The specific requirements for grounding and bonding will depend on the application and the local electrical codes. Sixthly, the selection of appropriate fittings and connectors is crucial for ensuring a reliable and compliant installation. All fittings and connectors used with the polyvinyl chloride conduit should be listed and labeled for their intended purpose and should be compatible with the conduit size and type. Additionally, it is essential to use proper installation techniques to ensure that the fittings and connectors are securely attached to the conduit and provide a watertight seal. Seventhly, consider the potential for electromagnetic interference. While Category 5e cable is designed to be relatively immune to electromagnetic interference, the presence of nearby power cables or other sources of electromagnetic radiation can still affect its performance. In such cases, it may be necessary to use shielded Category 5e cable or to provide additional shielding to the polyvinyl chloride conduit system to minimize interference. Eighthly, ensure that the installation complies with all applicable local and national codes and regulations. Electrical codes and regulations vary from jurisdiction to jurisdiction, so it is essential to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable requirements. This may include obtaining permits, conducting inspections, and providing documentation of the installation. Ninthly, proper labeling and identification of the Category 5e cable and the polyvinyl chloride conduit system is essential for facilitating future maintenance and troubleshooting. All cables and conduits should be clearly labeled with their purpose, destination, and any other relevant information. This will help to prevent accidental disconnection or damage to the cables during maintenance or repairs. Tenthly, regular inspection and maintenance of the Category 5e cable and the polyvinyl chloride conduit system is essential for ensuring its continued reliability and performance. This should include periodic visual inspections to check for any signs of damage or deterioration, as well as testing of the cable to verify its performance. Any issues that are identified should be promptly addressed to prevent further damage or degradation. In summary, installing Category 5e cable in polyvinyl chloride conduit is generally permissible as long as the installation is performed in accordance with applicable codes and regulations and best practices for data communication systems. This includes considering the fill ratio, bending radius, grounding and bonding, fittings and connectors, electromagnetic interference, local and national codes, labeling and identification, and regular inspection and maintenance. By following these guidelines, it is possible to provide added protection to the Category 5e cable without violating any national electrical code requirements. Additionally, consider that while the National Electrical Code doesn't directly forbid running low-voltage Category 5e cable in conduit, best practices for data cabling should still be followed to ensure optimal performance. Firstly, maintain separation from power cables. The National Electrical Code requires separation between low-voltage and high-voltage cabling. Though Category 5e itself is low voltage, induced electromagnetic interference from nearby power lines can still degrade signal quality. Maintain at least 12 inches of separation wherever possible, and more if running parallel for extended distances. Secondly, avoid sharp bends. As mentioned before, Category 5e has a minimum bend radius typically 4 times the cable diameter. Exceeding this can damage the conductors inside and affect signal integrity. Use sweeping bends for conduit runs and avoid kinking the cable during installation. Thirdly, use appropriate cable ties and supports. Secure the Category 5e cable within the conduit using appropriate cable ties or supports. Avoid over-tightening, which can compress the cable and impact performance. Use supports that are specifically designed for data cabling and are not abrasive to the cable jacket. Fourthly, consider future expansion. When designing the conduit system, consider the potential for future expansion or upgrades. Running additional cables later can be difficult if the conduit is already full. It's a good idea to oversize the conduit slightly to accommodate future needs. Fifthly, test the cable after installation. After installing the Category 5e cable in the conduit, thoroughly test the cable to ensure that it meets the required performance standards. This includes testing for continuity, shorts, and signal attenuation. Use a cable tester that is specifically designed for Category 5e cabling. Sixthly, document the installation. Keep detailed records of the cable installation, including the cable type, conduit route, and test results. This documentation will be helpful for future maintenance and troubleshooting. Seventhly, be aware of cable pulling lubricants. If needing to pull Category 5e cable through a long conduit run, use a cable pulling lubricant specifically designed for data cables. Avoid using petroleum-based lubricants, which can damage the cable jacket. Eighthly, use grounding bushings where applicable. If the conduit run enters or exits a metal enclosure, use grounding bushings to ensure proper bonding and grounding. This can help to prevent electromagnetic interference and protect the equipment from electrical surges. Ninthly, avoid overtensioning the cable. When pulling the Category 5e cable through the conduit, avoid applying excessive tension. Overtensioning can stretch the cable and damage the conductors. Use a pulling eye or other device to distribute the pulling force evenly. Tenthly, consider using pre-lubricated conduit. Some conduit manufacturers offer pre-lubricated conduit, which can make cable pulling easier and reduce the risk of damage to the cable. This can be especially helpful for long or complex conduit runs. By following these best practices, it is possible to install Category 5e cable in polyvinyl chloride conduit while maintaining optimal performance and reliability. Remember, always consult with a qualified electrician or data cabling specialist to ensure that the installation meets all applicable codes and regulations. Consider cable management practices within the conduit. Firstly, avoid mixing cable types. Do not run Category 5e cables in the same conduit as power cables or other types of communication cables. This can cause electromagnetic interference and degrade signal quality. Secondly, use separate conduits for different applications. If you have multiple Category 5e cables serving different applications, such as voice and data, use separate conduits for each application. This will help to prevent confusion and make it easier to troubleshoot problems. Thirdly, maintain proper airflow. Ensure that the conduit system allows for adequate airflow to prevent overheating of the cables. Avoid packing the cables too tightly together, and use conduit fittings that allow for ventilation. Fourthly, avoid sharp edges and burrs. Inspect the conduit and fittings for any sharp edges or burrs that could damage the cable jacket. Remove any sharp edges or burrs before installing the cable. Fifthly, use cable markers. Use cable markers to identify each Category 5e cable within the conduit. This will make it easier to trace cables and troubleshoot problems. Sixthly, avoid exceeding the maximum cable length. Category 5e cable has a maximum length of 100 meters or 328 feet for a channel, including patch cables. Avoid exceeding this length, as it can degrade signal quality. Seventhly, use shielded cable in noisy environments. If the conduit runs through an area with high levels of electromagnetic interference, consider using shielded Category 5e cable to protect the signal. Eighthly, avoid running conduit near heat sources. Avoid running the conduit near heat sources such as heating ducts or transformers. This can cause the cables to overheat and degrade their performance. Ninthly, use proper grounding techniques. Ensure that the conduit system is properly grounded to prevent electromagnetic interference and protect the equipment from electrical surges. Tenthly, document the cable routing. Keep a detailed record of the cable routing within the conduit system. This will be helpful for future maintenance and troubleshooting. Finally, ensure proper termination and testing. Firstly, use high-quality connectors. Use high-quality Category 5e connectors that are designed for use with solid conductor cable. Avoid using connectors that are designed for stranded cable, as they can damage the solid conductors. Secondly, follow proper termination procedures. Follow the manufacturer's instructions for terminating the Category 5e cable. Use a crimping tool that is specifically designed for Category 5e connectors. Thirdly, inspect the terminations. Inspect the terminations carefully to ensure that all of the conductors are properly seated in the connector. Look for any signs of damage or corrosion. Fourthly, test the cable after termination. Test the Category 5e cable after termination to ensure that it meets the required performance standards. This includes testing for continuity, shorts, and signal attenuation. Fifthly, use a cable certifier. Use a cable certifier to verify that the Category 5e cable meets the Category 5e standards. A cable certifier is a more sophisticated testing device than a basic cable tester. Sixthly, document the test results. Keep a record of the test results for each Category 5e cable. This will be helpful for future maintenance and troubleshooting. Seventhly, use patch panels. Use patch panels to organize and manage the Category 5e cables. Patch panels make it easier to connect and disconnect cables, and they provide a convenient location for testing and troubleshooting. Eighthly, label the cables and ports. Label all of the Category 5e cables and ports to make it easier to identify them. Use a labeling system that is clear and easy to understand. Ninthly, use cable management accessories. Use cable management accessories such as cable ties and cable trays to keep the cables organized and prevent them from becoming tangled. Tenthly, protect the connectors. Protect the Category 5e connectors from dust, moisture, and physical damage. Use dust caps to cover unused connectors.